Hello everyone, this is Vani from R.M.K College of Engineering and Technology. In this video, we are going to discuss one of the source coding techniques. So again, source coding technique, Huffman code, we are going to learn in this video. Also, we are going to discuss advantages of Huffman code. So the source encoder is responsible for the removing of redundant bits in order to save the bandwidth and power so that efficient coding is done and data is compressed. So the objective of source coding is to represent information as accurately as possible using as number of few bits as possible. So the redundancy is removed, which leads to compression, and it is also variable length code. So there are two types of coding technique. In the previous video, we have learned about Shannon-Fano coding technique. In this video, we are going to learn about Huffman coding technique. So whenever we are moving from one coding to another one, definitely the previous one might have had some drawbacks. So the drawbacks associated with Shannon-Fano code is that there may be two different codes for the same symbol, depending on the way the tree is built, right? So it is not optimal code, or even it is not following the instantaneous code or prefix encoding. That is a major drawback, and it does not guarantee optimal code. So Huffman encoding technique overcomes some of the drawbacks associated with Shannon-Fano. It is also a lossless compression technique. It uses variable length encoding. The characters which occur most frequently gets the smallest code, and the character which occurs least frequently gets the largest code, so that average length of the code is decreased and compression is achieved. So the procedure is the source symbols are listed in order of decreasing probability, which is same as Shannon coding technique. These two source symbols are then combined into new source symbol with probability equal to the sum of the two original probabilities. So we will understand this procedure while solving an example. The procedure is repeated until we are left with the final list of source statistics. The code for each source is found by working backward and tracing the sequence of zeros and ones assigned to that symbol as well as its successors. Let us understand this with an example where 5 symbols are given with the probability 0.3, 0.15, 0.25, 0.05 and 0.25 respectively. We are arranging the probability in decreasing order. That is the reason that here we are not having the same sequence. Here the sequence x1 followed by x3 with the next probability, followed by x5 with the next probability. X2 is having the next least, so 0.15, and x4 is having the least probability, which is 0.05, right? So let us see how we are getting this reduction diagram. Right, so what we are doing is we are combining this last two probabilities 0.15, 0.05. 0.15 is assigned with 0 probability. 0.05 is assigned with probability 1. Majority of the books are following this assignment only. In few books, it may be like here 1 and here 0, right? So when 0.15 and 0.05 are getting added, we are getting 0.2. As per the rule of Huffman encoding technique, we have to place the value in the descending order of probability. So in the descending order of probability, 0.3, 0.25, 0.25 and 0.2. So in the next step, we will be combining these two probabilities. We will assign 0 here, 1 here. If you see here, what we are doing is we are combining this two. 0 is assigned here, 1 is assigned here. And when we add 0.25 and 0.2, it is 0.45. So the probability is high. comparing with other two probabilities, keep as high as possible. There are two possibilities in Huffman coding technique. Either we can keep as high as possible or as low as possible, but normally as high as possible is done because that is more efficient compared to the other method. Now 0.45. So in the next step, we can see that 0.3 is brought below 0.45 and 0.25 is also brought below 0.3. Now let us combine 0.3 and 0.25 in the same way. Here 0 is assigned, here 1 is assigned. When we add 0.3 with 0.25, the resulting value is 0.55, which is more than 0.45. So the order of arrangement changes now. 0.55 is kept here, 0.45 is below that with the less probability. Now we are left with only two options. So we are assigning 0 here and 1 here. So as per the procedure, when we are ending with last list with only these probabilities, we can stop our assignment here. Now we have to find out the code word for x1, x3, x5, x2 and x4 by tracing the flow. So if we see the flow of 0.3, here it was in the same place, then brought down. Then again the 0.3 and 0.25 are combined and it is brought up. So if we trace the code of 0.3, it is following this path and with 0 and 0. But we have to always write the code in the reverse, 0, 0. In this case, it will not show any difference because both the bits are same. But when the bits are different, you have to keep in mind that the code we have to write in the reverse order. So the code word for x1 is 0, 0. Similarly, we can find out the code words for other symbols also. For x3, the flow is 0.25, 0.25. 0.25 is assigned here with 1. Then again it is combined and it is forming 0.55 with assigned value of 0, assigned code of 0. So what is a code word in the reverse order? The code word in the reverse order is 0, 1 for x3. For x5, again we are following the same procedure. 0.25, 0.25, 0.25, 0. It is contributing to 0.55. So when we are tracing, the code will be 1, 0. Similarly, we can perform for x2 and x4. For x2, the code is 1, 1, 0. For x4, the code is 1, 1, 1. Now we have to find out entropy and efficiency redundancy of this code. By using the same formula, we are having x1, x2, x3, x4, x5. We have found out the codes. We can write here. Apply the formula of entropy, average code word length, efficiency and redundancy. We can get the value. The procedure of calculation is same as what we have learned in Shannon-Fano coding technique. The efficiency of this code is 97.7%. The advantages of Huffman coding are it is giving the optimal compression, prefix properties followed by Huffman coding. It is a fast decoding technique and it finds wide applicability because of its good efficiency, simple and adaptability. At the same time, it has the drawback of potential for inefficiency in certain cases where Huffman coding is efficient for compressing data with the varying symbol frequencies. It might not perform as well on data where symbols have similar probabilities, right? Or when the probabilities change dynamically. In that case, it is not performing efficiently. Compression overhead is another drawback of Huffman encoding, where the drawback of overhead is in the form of codebook or tree structure that needs to be transmitted along with compressed data. So for very short messages or in specific cases, this overhead might offset the compression gain. In spite of these drawbacks, Huffman coding is used widely because of its simplicity and efficiency. So as a summary, we have learned one of the source coding techniques, which is Huffman coding technique, and we have discussed the advantages and disadvantages of Huffman coding technique in this video. Thank you.